All right. Okay, so let me continue looking at our discussion that we're having this week about the templates for the project that I'm suggesting that you can use if you want. Let me show you. I added a couple things that I'd like to share with you. So what I added was the ability of having several users come in and interact with the movies that they're looking for and be able to like them so that they can be stored in their database, so that when you come to your profile, you can see all the movies that you've liked so far, and that when you go to a movies details page, you can see all the people that have liked that particular movie. So if I log in as actually, if I don't log in first, right, and I go to search, and I search for a particular movie, and I navigate to the details page. If I'm not logged in, if nobody's logged in, and we click on the likes button, since no one's logged in, it kicks you back to the login page. If instead I am logged in, and I do the same search, now if I do like that movie, it doesn't kick me back to the login page. And whenever I go back to the profile page, it shows that I've liked that movie, right? If I do more searches and click on Batman Returns and I like, if I go back to my profile page, I have all the movies that I've liked so far. I can then navigate back to that particular movie, right? Or this one, or the image. It goes back to the details for that particular movie. Notice that down below I have other users that like this movie, including me. Right? So maybe a better title for this would be all users that like this movie, including myself. Right? If I log out and I log in as someone else, it's Bob, and Bob searches for the same movie, and Bob is going to like the same movie, right? They can see that Alice has liked this movie. If I like it and I go to my profile, I have my movies that I have liked. If I log in as Alice, Alice will see the movies that she likes, right? If I go back to Batman, you'll notice that both of us are listed now, right, as people that like this movie. Another feature that I'm working on that I'm not done yet is being able to click on Alice and Bob and navigate to their profiles. So I'm logged in as Bob, but clicking on Alice would navigate me to Alice's profile. It would list what he likes. Right now it's just listing my stuff, right? The currently logged in user. So I'm not done. Notice there's a profile here. It's a little bit different. So it's profile/username, right? So presumably I'm looking at somebody else's profile, right? I'm logged in as Bob, but I'm looking at Alice's profile, right? So this profile page should be a little smart and identify and determine what to show depending on who's logged in, whose profile am I looking at, right? And show me somebody else's profile information. Also, for instance, if I'm logged in and I'm listing the movies that I like, one of the options that I should be able to do is click on maybe on unlike, right? And then it would disappear from the movies I've liked. But if somebody's is visiting my page, they shouldn't be able to edit my likes, right? They should be able to view the movies I like. Maybe there's a like button there, but the like button pertains to them, right? So any CRUD operations, right, that would be pertaining to the person who's currently logged in, right? It's not pertaining to the user that you're looking at. You're not changing Alice's likes. You're changing my likes, right? The currently logged in user. So I'm not done with that yet. but I wanted to share with you the implementation of these relationships. Okay, so to be able to support this kind of this kind of information about if I'm looking at a particular user, I can see the movies that this user likes, and I should be able to support the fact that if I'm looking at a particular movie, I can see all the users that like this this movie. To be able to support that kind of data structure, we have several options. One of the options is the classical way of capturing this would be to have a user collection, right, and then have a movies collection, right, and in between have a relationships in between, right, where you have maybe these likes, right, and likes has references to the users and the movies, right. So for instance, in the users collection, you might have two users, user 1 and user 2. And in the movies collections, you might have movie 1, movie 2, and movie 3, right? And you like to be able to capture the fact that user 1 likes just movie 1, and movie 2. So you might capture something like user 1, movie 1, user 1, movie 2. Right, so we've captured the fact that user 1 likes 2 movies, and user 2 might like also movie 2, but they also like movie 3. So there's kind of like an overlap, right? There's 2 users that like the same movie. So this kind of this kind of data structure is referred to as a many-to-many data structure, right? That allows me to capture for one user, allows me to capture several of these. So there's several records on this right-hand side for every one on the left-hand side, right? Given one user, I have 2 in this case. I could have 3, 4, 5, any number, right? But on this side, on the movie, it's also a one-to-many relationship, right? Where for one instance, on this right-hand side, there can be several on the left-hand side, right? So, for instance, for movie 2, notice that there's 2 of these, right? There's 2 of those, right? There could be 3, 4, 5, any number, right? So again, this is a one-to-many and a one-to-many, right? We usually refer to this as a mapping table. Okay, and this could be used for all sorts of things, right? You can have it also for reviews, right? In a review, you can have, again, user 1 is reviewing movie 1, right? And then the content of the review. Okay. Usually we refer to this. This also would be a one-to-many and a one-to-many. So it's a many-to-many, but we refer to this kind of association as an association, right? As opposed to just a mapping table or that creates relationship between these two. This is necessary to implement the many-to-many, right? This one we call it association, which is explaining, right, or is capturing some information about that relationship. Whereas this only says that these 2 records are related to one another. This says not only are they related, I am describing or decorating that relationship, right? I'm capturing information about that relationship, right? Like a review. Okay, this just says that these 2 are related to one another. Nothing else. That these 2 are related. Our interpretation is that this relationship is a like, right? That this user likes that movie. Okay. Also, notice that this data model allows us to navigate the data from both ways, right? Given a user, right, I can determine all the movies associated to that user. But from the other way too, right? From the other point of view, if given a movie, I can determine all the users that like that particular movie. See that? All right. So this is the classical way of implementing this in a relational database, but we're not going to be using a relational database, right? We're going to use a NoSQL database. The NoSQL database is going to allow us to do this as well, right? We could do this, and that's certainly a legitimate way of implementing it, right? And you're certainly welcome to implement it this way. But being an object database, right, where you can store actual objects in the database, you have other options, right? Not only do we have this classical way of implementing it with the many-to-many, right? We have other ways of doing it, right? And I want to talk to you about one particular way of doing it, right? Because these objects, because these records here are more than just one flat record, one flat row, right? The way we normally implement this in relational database, these are actual objects, right? They're JSON objects, right? They're not just a row where you have name value pairs, right? Where you have field value, field value, field value, field value. That's what a row is, right? A data element, right, can only have one value, right, and it can have one single data type. Although that data type could be a blob, right? You could store an entire object there, but nevertheless, it's typically you normalize the data, right, and everything has a strongly typed value, each cell, right, each field. In an object-oriented database where you can store actual objects in there that have a schema, each object has a schema, you have other options. You could, instead of using this way of storing the data, right, we have the option that object. So you could, an object can have elements in there, right? Not only can it have fields like a regular row, right? Where you can have first name and last name and username and password. That looks very much like just fields in a record, right? In the regular SQL implementation, right? But you can have other objects in there. You can have an array. Okay, the object, the field could be a multi. It could be another object, maybe like an address, right? And the address could have other things in there, right? It might have street. It might have state, right? What? Address 1, address 2, right? It might have a state. It might have a zip code, right? It might have country. So you can have an entire object stored here. See that? Right? And one of those fields in there could be an array of other objects, right? So you could have a fairly sophisticated JSON instance, as a record, and we don't call them records anymore. We call them documents, right? It's an entire JSON document stored in there, right? Yes.
So instead of having this array into this document, this collection, we can create a new collection, right, of only which is having, suppose, the ID and the list. Because it's not like that if we put so many, so it would be big list, right? So if we put that big list into one single document, then that JSON would be like very it would be jacked up with so many.
Right. So this array, so in this array you could store whatever you want, right? What we're going to be storing here are just references. We're going to be referencing movie 1, movie 2, movie 3, the movies that we are referring to, right? We have the option of storing the entire object. We could do that, right? The entire movie 1 object stored in here, the entire movie 2 object stored in here. Okay, that would be okay if there's a one-to-many relationship, right? Where you have one user and then instances of those objects, unique instances of those objects stored in this array, right? Where those objects only live in this user 1, right? That would be a better solution, right? You don't have to join. The data is already there, right? But if that movie instance is shared amongst many users, like a many-to-many as opposed to one-to-many, then you're going to have redundancy, right? You're going to have this movie 1 copied many times over several instances of users, right? You're going to have several references, and you're going to have redundancy. You're going to have risk of inconsistency, right? What if you update one of the instances here, but you forget to update it elsewhere, right? A better implementation is to have these being references to unique instances that live elsewhere, right? Live on that collection. So it depends, right? In general, right, the preferred way of implementation is that you do have those instances here, right? If you're not going to run into inconsistency or redundancy, right? So in one-to-many, if you have one-to-manys, definitely that's the way to go. In a many-to-many, it's better to either have just instance references or a mapping table. Yes.
Because if we have both objects at both the location, then we have to do.
You have to update everywhere.
Everywhere.
Yeah, exactly. And you want to avoid that. Yes.
In such a case, I mean, since there's a one-to-many, it's a many-to-many relationship.
Yep.
And you just have instances on the either the user side or only on the the object side, the other side,
yep.
the side. Wouldn't it take more computation time in case when you have to list other users which like this movie, because you have to do a cross-reference to find that out.
Yes, you're gonna have to rebuild this, right? You're gonna have to, just like what a join does, right? A join does this where you have these three tables, and these three tables are joined by these references, right? And the way the database does that is just iterates over each one, right? Where they match, and then they give you back a result set, right? And relational databases are, they're very good at that, right? That's what they do. They join, and in MongoDB, it's not built for that, right? MongoDB is not built for joins, right? Instead, they provide all sorts of functions that allow you to iterate over these, right? And map several functions, right? And map reduce the function, and as they iterate, they create the result set for you. Right? So you have to explicitly explain how is it that you want to join these things, right? As you iterate over these, right? Grab these, objects from here and grab that, and I'll show you how to do that, right? I wanted to show you how to do that. Even if we would have the mapping table in between, we would still have to iterate and build it ourselves. There are no joins in MongoDB. They're not built for that. Yes.
So if we are going to iterate, then why don't we separate out that array list into a different collection altogether?
Yeah, that would be back to the mapping table.
No, I'm not talking about mapping table. It's like for that username.
Yeah.
I'll have, because if we are going to iterate over every object in one particular collection, then first we have to take care of the fields. Then we come to our list. Then we again go to in that list and iterate. So there would be two iterations, right? First iterating over the field. Once
you're gonna use the two iterations regardless, right? Because first you need to find out what are all the movies for a particular user. Once you have those IDs for those movies, you're gonna have to iterate again over the movies to find out what the movies are. So there's no way. It's always gonna be squared. It's order squared. And if it were a relational database, it would be cubed, right? Because you have to iterate over three tables, right? You have to iterate over users, you have to iterate over the mapping table, and you have to iterate over the movies table. So it would be order cubed anyways. Yes?
So then how do we decide which is a better trade-off? Because computationally, it's better to have redundant data, or it's better to do this type of computation.
Right, so when you end up doing something, and we cover this in 5200, is that you have views, right? And views allow you to have pre-compile or computer things. It's a managed redundancy, right? Where you don't manage the redundancy. You have the database manage your redundancy, right? So that you have it pre-computed here, where you have the objects already there, right? So when you go fetch it, it's already there. And if there's any modifications in that data structure, those data structures are recalculated everywhere, right? And MongoDB does support these kinds of operations. Well, managed redundancy, we call it, right? Yes. You have a question? Yeah. All right. So there's many options. This option is not available in the relational databases, right? So I wanted to show you what that might look like. Even though we're not talking about databases yet, right? We're talking about these arrays living in the memory of the computer, right? Of the Node.js, right? And we're explicitly iterating over these data structures. So just to show you what MongoDB would have to do in the back end, right, to actually join these things together. Okay. All right, so let's go back to some of the check-ins that we were looking at yesterday.
let's on Tuesday, we created the login controller, the profile. I think we got as far as to the profile and searching the movies, right? We did searching the movies. Did we do that? Being able to search movies. Did we do registration? I think we did all the registration, right? Being able to log in, being able to register. Did we do that? I don't remember. Did we get a file? Okay, let's quickly review some of these things. Okay, so we certainly covered this, right? Being able to, once you log in, being able to store that user in the session. Right? Did we talk about the session? I think we did, right? Once you log in and you find a user, we store it in the session, and I believe we talked about how to configure the session. Create the server model, how to create text or yeah. And then we went back and then made sure we can protect the profile so that people can't navigate to the profile unless somebody is logged in. We covered that, right? Yes.
Yes.
It was using a resolve, right? We covered that, right? And we refactored log out, so that log out would go out to the server and clear out the session, right? If you logged out, we cleared out the session, right? We covered that, right? We talked about that on Tuesday. We added registration, right? Which was just a form for you to be able to create a new user, right? With two passwords and a username. We added a link to be able to register and a controller that received the user. We added the registration controller to the registration view. Here's the boilerplate implementation of the registration controller that is receiving the register from the event handler when you click on the button to register, right? Please stop me if you want to review any of this. Yes.
So one question. So edit function. So how it does is whenever we initialize register controller, by default call the edit.
Yeah, that's a convention.
But so there is so I just read in Angular documentation there is NJ init. So it is different from this.
Yeah, it's different. Yeah, from the init allows you to initialize the entire application, right? Where you might go off and update, create certain data structures, right? And that you will need later on throughout the application, right? Initialize some variables, initialize some root scopes that will be needed by the time the application comes to life, right? This is equivalent, but at a controller level, right? Where this is a convention saying that any use of a service, right, that we want to execute at the time of instantiation, we want to explicitly encode it in this function, right, that will be executed when the controller gets instantiated. This is just a boilerplate function that gets invoked from the user, from the registration page. We added a create user to the client, right, to the user service client, which is going to do the heavy work. Going to go talk to the server, right, and create this brand new user. The controller, we injected the user service in the controller, and instead of just echoing the user object to the console, to delegate the creation of the user to the service, right? And the service will delegate the work to the server, right? The client is instead of just the user service client, instead of just echoing the user, is going to send the user to the server in this new endpoint. Right? It's going to pass a user object. On the server side, we're gonna update the user service server and listen in for that incoming post coming from the client. and we're going to invoke the register function on the server side. Right now, we're just echoing the user that we're going to extract from the body, just to verify that the clients and the servers are talking to one another. Right? Again, baby steps, and always verifying that that the incremental piece of code is working. Right? Don't create a lot of code and then expect that it works. Right, make sure that you do a baby step, test it, okay, very good, commit it, and then you go and do another baby step. Right, making sure that from one commit to the next, you're always at a stable state. Right, that any change that you make, it's always releasable code. Right, that you can commit it, somebody can look at it, somebody can clone it, and it's working code. Right, even though a feature might not be done, right, but it's not, doesn't break the server, doesn't blow up anything. So on the server side, the create user on the client, instead of just the service on the client is going to post to the register. I thought we did this. Wait, am I looking at the same thing? Yeah, I'm sorry, I'm looking at the same thing. Sorry. Okay, there we go. So the service on the server is going to delegate the actual creation of the user to the server, to the model. Right, the model is the one responsible for manipulating the data. Right, the service is only responsible for being the interface between the HTTP world and the object world. Right, it's responsible for parsing everything from the body, parsing the URL, parsing the query parameters and things like that. Right, and it's the interface that world in the object world, but it's not responsible for actually manipulating the data world. Right. Instead, we have a dedicated module called in this case will be the user model module. Right, that will be responsible for manipulating the data. We had mock data already that we were using for the login, implementing the login feature, but I have forgotten to add IDs to those objects, so I went back and added the IDs. In the model for the user, we only had find user by credentials that iterated over the mock data, looking for users that had a username and password. We're going to add an additional API method that allows us to create users or add to that array of users. Right, and it's going to be invoked by the service. The service is going to parse it from the HTTP, and it's going to pass it to us, the model, and we're going to push it into our data structure. Right, so from the service, it's going to use this create user in the model. Right, and pushing the sending the user to the model to be added, and we're going to make this current user who's registering the current user who's logged in. I'm going to add them to the session, making them the current user. So if you register successfully, then we're gonna log you in. You're logged in. Okay. In the model, we might have added some business logic here where if you're ready to register, we wouldn't let you register again. Right. So we might do some validation here. First, check to see if there's already a user that has the same username. Right, and we would be validating things here in the model, making sure that the model is always correct. We could validate it on the service side as well. Right, again, we validate often and as early as possible. We can't validate it on the client side, right, because we don't have a list of all the users. Right, we have to rely on the server for this kind of validation. Right, if we would have data on the client, we would validate right on the client as early as possible. Right. So once we have validated that the user has registered, it'll come back to the controller, right? Because the service, the client sent a post, right? And that post is responding with the current user who's logged in, right? And so the controller that had made this this invocation, notice that initially it had just made the invocation. It wasn't doing anything with the response, right? The client, the user client, is going to respond with a promise, right? And what we're going to do is that we're going to capture that promise, right? We're going to register a callback. There's a callback right there. That's going to be invoked with the response of the user who's logged in. or not, right? And what we're going to do is that we're going to if a user back, then that means that that user has been successfully logged in, right? If a user comes back as null, something happened, right? Maybe the user already existed or some error happened, right? So we're going to check for that. If there is data in our response, then if there's data, then we're going to say, okay, well, they've been success. I'm assuming they have successfully logged in. I'm going to cache that user in the root scope, right? Only for convenience, right? So that everybody gets notified, that the home page gets notified, the profile page gets notified. Everywhere the current user variable is being displayed gets notified, right? But this is only for convenience purposes. We could always go back to the server and fetch the currently logged in user. Actually, that's what we do eventually, right? We do that for the home page. We did that for the home page, right? And for the search page, right? We always go back to the server to see who you're logged in, right? So this is only for convenience purposes. Also notice that because you have successfully registered, we're going to let you the profile page, right? We're gonna present you with a profile page because you are now logged in. Okay. Again, if I'm going too fast, please let me know.
Can
and
you
we can
just explain again about the promise? So I just
Yeah.
So how it exactly?
Oops. Wait a minute. Right. So if you remember, the implementation here was it used to be when we used to use callbacks. Did you follow the callback?
Yes.
Okay. Well, that mechanism of the success, that success mechanism is exactly a promise. It's as if we were doing the then there, right? We would say dot then, and then we would register a function that would be called in there, right? Right. So the success is the older way of doing promises, right? It's using the dot then. It's a newer API, right? That conforms to how promises are managed across many frameworks, right? In the Node.js, we use the same exact nomenclature, right? You're using then and providing two functions, one for success, one for failure, and so this is just using that. And so what we're doing is that instead of handling the promise using .success at the service level, right? What was that doing? It was saying .success, and then you provided the name of the function, right? Well, instead of doing the .success in the service, right? The signature of the function was that you had http.get or post or whatever, right? And then that object returned that call returned an object which we then call success on it, right? So instead, we could just return that object to whoever called us, and we could do a success here, right? Because this function just returns exactly the same object that I would be using in the user service, isn't it? So what I'm doing is I'm just kicking the can later. It says I don't want to handle it in the service. I want to handle it in the controller, right? So this I could have written here .success instead, and this would have worked just the same, right? Now the .success, again, as I said earlier, it's a more legacy API, which allows us to have two different functions. One that was invoked if it's successful, and another function, error, if there was an error, right? Instead, this API is a little bit different, right? But it accomplishes the same thing. The .then API allows us to provide two functions, right? One of them is right here, right, which would be invoked if the call is successful, and I could continue to say comma, and then another function, which will be invoked if there's an error. Okay, but I was lazy and I didn't provide the error function. Okay, so it's just a different signature, but it accomplishes the same thing.
So now the create user won't give us back the callback function. It would just return
the promise. It returns an object.
Returns an object
that has a function called then. Right, it has a function called then. It also has a function called success, which we were using before. Right, But in that signature, when we were using the success in the service, right, forced us to pass the function in the call. See that? Because it was using the function in the service. This way of doing it instead doesn't force us to pass the callback, right? Instead, it allows us to register that function outside of the function call, right? Outside of this function call, right?
Can you just once again go to user service?
User service, yep. Nope. Service. Yeah, there it is. Create user. Right. The only thing it's doing, it's returning whatever the post returned. See that? So this used to read. This used to be $http.post, whatever, right? .success. Right. Remember that?
Yeah.
So that .success was being invoked on an object that the HTTP post was returning. See that? Right. So instead of handling it here, I'm just returning it so that my parents can deal with the callback instead of me dealing with the callback, right? Okay, and that callback is being provided right here. Okay, so what we're doing is that we are deciding that the responsibility for handling the response is not the user's responsibility. It's not the service's responsibility. It's the controller's responsibility. It's basically we're shifting responsibility to the controller. Okay. Also, it makes the service much cleaner, right? It doesn't burden the user service with the fact that it has to deal with these callbacks, right? You know, as far as the user service is concerned, it should be only concerned with manipulating the data. Right, not who's handling the data, right? What you are doing with the data. The controller is the one who's responsible for saying, okay, well, what do I have to do with this data? Oh, the view needs it. Right, I'm going to pass it to the view. The controller is the one who the controller is the interface, right, between the users handling the data, right, and generating all sorts of a stream of events, right, and then its responsibility is not to manipulate the data, right? The responsibility of manipulating the data is the service responsibility, right? It just says, okay, these are the stream of events. It says, I don't know what to do with this, but it knows it knows what to do. It knows what should happen, but it doesn't know how to do it, right? It delegates that to the service. The service, hey, service, they want to create a new user. I don't know how to create a new user. The service knows how to create a user, right? And says, well, do your thing, right? And then it comes back, says, hey, I'm done creating the user. Oh, thank you. Now that it has this new user, it has the added role of deciding, okay, well, what should the view see next, right? Should they see the data now, or should it be a new page that renders that page? That's a controller's task. That's the role of the controller, right? Mapping user actions, and then providing data to that user. But it's not responsible for manipulating the data, right? It delegates that to the service. Okay, make sense? And the service should be generic enough that it could be used not only by this controller, right? It can be used by anyone, right? It's going to perform the action of creating the user, but then it's going to notify, hey, I'm done, right? It's not responsible for knowing that I need to call this, that, or the other. Make sense? Right? It doesn't know. It should not be responsible for that. Yes?
So we get back the currently registered user from the HTTP request.
Yes.
And so here, where current user is equal to response.data. So
yes.
So whatever response is there, whatever object, JSON object we are getting, so
yep.
it's stored in data.
Yeah. So it used to be when we used to the success, when we weren't using promises yet. That success, we were receiving the raw object that was coming back from the server, right? Promises wraps this raw object, right, in a parent object, right, in a response object, of which one attribute in that response object is the data attribute. And the data attribute contains the raw response that came from the server, plus some other metadata, right? Like the status, like the HTTP status that came back from the server is also part of that meta object. Okay.
So we can check their HTTP status also if there was any error.
No, the HTTP, yes, right. But so right, any error codes would be part of this meta object. Would be part of that. Yes. Yes.
What is the role that is a service playing in VC model? Is it just a bridge between a controller and the model?
Right. So exactly. So the service responsibility is to first of all give a modular access to the data, right? So that it's not spread across controllers. So there's one place that is responsible for manipulating the data, right? It can be shared amongst many controllers by injecting the user the service into many controllers, right? For instance, interacting with the OMDB API, we should have a module that does that, right? And then we can share it. We can share it in the search page. We can share it in the details page. We can share it maybe also in the profile page. It can be shared amongst many pages. So instead of spreading that logic across many controllers, many pages, we have it modularized in one single place, right?
So it's DAO. Data, something.
It's like a data DAO, yes, like a data access object. Well, we could. So all these are all very multi-tiered applications, right? Where you clearly define several tiers responsible for their little piece, right? Another tier that we might consider here, excuse me. Another tier that we might consider is a model tier. Okay, a model tier we could use for instance, mapping representations of objects that live on the server side. Like for instance, we don't like the objects that OMDB is giving us, right? It's using the naming convention is kind of weird, right? It's using capitalized stuff. The schema that it comes back, we might not like it, right? So there would be a model tier, right, that would convert between the data representation and schema, that the raw schema that is coming back from any servers, into a schema that is more like useful for rendering, right? It might do some collation, right? It might do some summary, right? It might something that is flat, it might convert it into something that is more how do you say, what is it called when you go a data model that it's into several objects, right? That is more hierarchical as opposed to it's flat, or vice versa, right? The object that might come back very hierarchical, right, and had a lot more data than we really care for, and we might want to flatten it out so that it's easier to render at the view. So the data model at the client's point of view, right, might be flatter, okay, than the data that might be represented in the data model in the server, right? So that conversion might happen there. We might also add another tier, which would be the API tier or the HTTP tier, right? That would do some conversions, right? Maybe it would be intercepting a couple of communications that might be encoding certain data that might be useful for the server. The server might want certain things in a certain format, right, or encoded in a particular way, right? And so you might have those kind of issues in that tier, right? The HTTP tier, right? That would be the last conversion once it becomes raw HTTP, right? Kind of like the inverse of the service on the server side, right? Again, it depends how much tiers do you want, right? How deep you want your tiers.
So so it's like if you are writing an interceptor on the client side. So is that good or?
Yeah, interceptors, right? It could be, you could have two interceptors. One we're using here, an interceptor that we're using from the user interacting, going to a route on the Angular side, which we're doing, right? The resolve, those are interceptors, right? But they're intercepting the users as they interact with the client, with the UI, right? You can have interceptors on the other end, right? On the HTTP side, right? All in the browser. This is all running on the browser. Intercepting HTTP calls, right? Calls are coming back from the server, right? That the data that might be coming is encoded in a weird way, right? That you might be decoding it, maybe they're using URL encoding. Maybe we're not supporting cookies, so the JS session ID is encoded in the URL, right? So all those low-level HTTP things would happen in the HTTP layer, right? Which would create a higher level for the model. The model would then do mapping that might flatten out the model, right? Or normalize. That's the word I was looking for. Would normalize the data more, right? For the front end, right? And then provide that to the service, and the service would provide it to the controller, right? I think that's going too far of having such a hierarchy. What you end up often what you end up having when you have so many layers is that you have just a lot of proxy. The APIs look very similar to one another, right? So the user server has an API. The model one has an API. The service layer has look very similar to one another, right? And even though there's a lot of effort at the beginning of wanting to have this very cool, very tiered architecture, the truth is that it's often not realized. Right? What the original intent of having all these tiers is not realized, and you just end up just calling each other, calling, and not doing anything in between, right? But nevertheless, you should consider, right, with really large applications, you benefit from these multi-tiered because you have in large teams you can have teams that are dedicated to these various tiers, right?
It's like we are moving towards the development how a Java web application or
right. So exactly, we're copying. We're learning from other very mature frameworks, Java or C#, right, that have been around for quite a while and have solved all these issues on the server side, and we're trying to replicate. I mean, the original intent of those frameworks is to get up, right, to be able to manage complexity, right? That was the original intent. How do we manage? And we came up with a lot of design patterns so that if you break it up into all these tiers, then it's easier to manage, right? It's easier to have teams dedicated to different tiers. And we're trying to replicate the same, because complexity has grown on the front end, because we want to be more interactive. We want to provide better user experience, and applications behave like desktop applications. The complexity has grown, and so we are applying design patterns that worked well on the back end. Now we're reapplying them in the front end. Yes. Okay. Yes.
So look at how do you pass the user object from the client side to the server?
Oh, the register view. The register view just had a model.user, right? And the model.user as model.user, right? And then the controller just received that user in the event handler. So this is the event handler that gets called when you click on the button, right? And just receives a user here, and then we wrote the service, right? So we can pass that user to the service, right? Then the service, here's the service. The controller, instead of just echoing the user, is going to use the user service. Is going to delegate the creation of the service to the creation of the user to the service, right? The server receives it, and right now it's not doing anything, right? But eventually, it passes it, right? It passes it to the server, right? It relies on the server. It delegates the creation of the user to the server. It passes the user object to the server, and the server retrieves it from the body.
Oh, yes. So the user object would be embedded in the request.body.
In the request, yes, yep. So the service, when it does the post, right? When it does the post, notice that here's a post. It passes the object instance as part of the post, right? And what ends up happening is that the user object gets embedded in the body of the HTTP request.
what if you have like a user and another object?
You would embed the objects in a larger object and pass that object.
So dot body and then
Dot user, yeah, and then the body would contain two objects, right? Right, as part of one bigger object, right? So say for instance you want to pass the, say you want to create a review, and the review needs the user who created the review and the movie that was reviewed, right? Plus the content of the actual review. So you can embed that in one big review object whose attributes are user, which contains the user object, movie, which contains the movie string, content or review string, right, which has the string that you just wrote, right? And so that's one big object that would be passed here, right? And then on the server, you extract the body, right, the review, and then from the review you can retrieve the user object, saying review.user or review.movie, right? So it would be you would get the same exact object that you passed along with the hierarchy and the embedded objects and whatnot. You would get it back on the server in the dot body. Okay. Yep.
Professor, and why are we not passing the user object back from the server?
Back from the server. We didn't do that yet. We do that in the next step. Right now, it's just echoing the user object. Again, baby step. Right. Got the user object on the server. I'm not doing anything with it. I'm just echoing it to the console. So in the next step.
So my one question over there. So in that code, so if we have something that puts back into our database,
yeah,
and still we would like we will send the response as response.json and that user.
Yeah, and we'll do that.
Okay, and that response. So when it gets back to our user service on the client side, it gets wrapped with a response object, and in the controller we'll take from response.data. Am I correct?
The controller, wait a minute, user, client service.
So we will return whatever.
Yeah, see this, right?
Okay, so we will return everything from there.
Yeah, it returns a promise.
It returns the promise.
And that promise, you can then register a function that is going to be invoked when the response comes back. Right? And that response is going to contain a data.
So how that wrapping takes place? My question
so the dot then does that.
Okay,
the dot then, right, receives the raw object that comes back. It creates a new object, right, with the status, the HTTP status, with any errors, blah, 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 and a new data attribute whose value is the raw response that comes from the function. And then it passes it to you, to whatever function you registered.
So before that we were losing the information about the metadata about the response, but now we have.
We're not losing it. It's it was part of the headers, right? You can retrieve it from the header, right? The response you can ask for the headers too. Create user service, server source. Okay, we did that, right? So right now the service is just receiving and just echoing the user to the console. But we're gonna add it. So the user service, instead of just echoing it to the console, right? It's going to use a model. The creation of the user to the model. Remember, services don't manipulate the data; they rely on the model to manipulate the data. They create the user. They use that new user that has been created, right? And there it is. They return the user in the JSON, right? And they store it in the session, remembering that this user just registered, and that this is by default the currently logged in user. Yes. The model we used to have just find user by credential, and we added this new create user function. That is going to create a dummy ID that is unique. A unique ID is going to add the user to the model, right? To the mock, right? Remember, the mock was just the array of users, right? and then just return that user. We're gonna come back to this later on when we cover MongoDB, so that this is an actual insert, right? It inserts in the database. This will when we start talking to the database, this is going to be an asynchronous call, right? Because the database can be in another server. It's running in another server. We need to make a network connection, right? Send the data over the wire, right? And that might take a while, right? So just like the browser sent us the request to create the user to register, now Node.js needs to make a query, right, to the server, passing the data to the server. So just like the browser is waiting for our response, right? It's waiting in the promise, right? It's waiting. Same thing, that Node.js is going to have to wait for the server to come back saying that it was successfully inserted, right? So just like there's promises on the client waiting for the Node.js, Node.js will have to handle promises from the database server, right? That's going to come back saying, yes, I was able to insert it, okay? And here's the record that I inserted. And then once that resolves, we can then send the request back to the client, and the client will resolve its promise. See that? So it will be a promise within a promise, right? So that's going to be a good. Right now, we don't need that, right? Because these are all synchronous calls of functions running in the same memory space of the same server, right? So these are all synchronous, right? A function calling another function, right? Blocking, waiting for the function to come back.
Then why this is a asynchronous call? We can keep this also synchronous.
No, this is synchronous.
So when we connect with MongoDB also.
Oh no, with MongoDB will be asynchronous. Will be asynchronous. That's why the promise is.
But why we want to have it as?
Why we want to?
Yeah.
Is that we want to, right? It's I mean, we could force MongoDB to be a synchronous call, right? Each function to the database has two versions. Has a synchronous version and an asynchronous. So the asynchronous is that you have a multi-thread environment, right? And you don't want to block, right? Otherwise, you would block the server waiting for this to come back, right? And there's a whole bunch of other requests that are coming in that you would be you'd be busy waiting for the database to come back. Instead, you're gonna say, okay, well, go insert this. Meanwhile, let me go handle, right, these other things. Right, and then when you interrupt me that the request came back, then I'll talk to you, right? And it might take several milliseconds, right? During those milliseconds, I can handle a dozen requests coming from other users, right? And then come back to you. So it's a much better use of resources using asynchronous calls, right? We just have to write it knowing that these things are asynchronous. Okay. All right, so we did this, right? User model, create, yep. So right, so the controller was waiting, right? And here's the implementation of of handling the promise, and we navigate to the profile page when you successfully registered. Okay, so. But up to this point, we have protected only the profile page, right? And by writing the resolves, right, that we covered earlier, and the way it works is that it goes and checks to see if somebody's logged in, right? On the server, it comes back. If it's successful, it resolves the promise. If it's not successful, it rejects the promise, right? We covered that previously. And because of this, the profile knows who's currently logged in, right? And every time you refresh the page in the profile, it goes and fetches to see who's currently logged in. So I always know if I'm in the profile page who's currently logged in, if there's somebody logged in. If not, I'm going to kick you back to the login page or the home page, whatever. But if I go to the home page, right, the home page is still using the root scope to identify who's currently logged in, right? But if we refresh the page, if you remember, we would lose who's currently logged in because the root scope would be cleared, right? And I wouldn't remember. I could not survive refresh pages, right? Page refresh. So what we want to be able to do is provide session support for some pages. Maybe the home page, I like to provide session support. For instance, if I know who's logged in, I might provide a customized page for that person, right? Maybe the latest movies that you've reviewed, or the latest movies that you've liked, right? If I know who you are. If I don't know who you are, I might give you a generic page, right? So to do that, one alternative, yes.
With respect to the session,
Yes.
I mean, is it like you can, have a current user for the entire domain together, or we can make it page specific?
Page specific. What do you mean?
Like for example, I've logged in,
Yeah.
so I can have that in say home page, profile, and register.
Yep.
But if I have another say search results page or some other page XYZ,
Yep.
I don't want that specific user. It doesn't matter if the user is logged in or not for more than XYZ page.
Yep.
So the session, if I say set the session to this particular user,
Yep.
is it that he'll be present for all the 4 to 5 pages, or it'll be just the 3 pages which I specify?
Right. That's exactly what I'm talking about here. Right here, I want to provide session support for certain pages. Maybe not all of them. Maybe login page. I don't need to. Right. Maybe the contact page. I don't care. The about page. I don't care. Right. It's always going to be the same page regardless of whether you're logged in or not. Right. But if I want to provide some customized content, maybe on the home page, right, or maybe on the search page or the search details. The search details page, I might have certain things that I like to show. For instance, the like button, for instance, should be customized, right? If you know who I am, you should know that I've already liked this movie, right? So you should highlight that this movie I've already liked, and you should turn the icon to an unlike button, maybe, right? See that? So certainly the details page needs session information about who's currently logged in. If there's no one logged in, maybe I don't even give you the like button, right? I don't even give you a box to input a comment or to rate it, right? If you or maybe I provide it to you, but I know that if you're not currently logged in, I'm going to kick you to the login page. So instead, if you are logged in, I give you the comment box, right? I give you the rating link. So it's somewhat customized based on whether you're logged in or not. So how do we do this? One mechanism would be that each page just goes off to the server and finds if there's anybody logged in. But that would be burdening each controller with the task of finding who's logged in, right? And we don't want to do that. We don't want to spread that logic across many controllers, right? It would be redundant. So we want to have a central place where we can do that, and that it would be framework-wide, right? A single place where we can find out and apply these session features to certain pages, but not others, right? So to do that, we're going to use the same resolve mechanism that we used earlier for profile to protect those pages, right? We're protecting the profile. In this case, we're not going to use it to protect the page, right? We're not going to protect anybody be able to see the home page, regardless of whether they're logged in or not, right? Also, the search page, we want everybody to be able to use the search page, regardless of whether they're logged in or not. Right? That's one of the requirements of the project, right? That a lot of the features are available even to people that are not logged in, publicly available. But if you are logged in, I want to give you access to the session information. So we're going to use the same technique. We're gonna intercept your route if you try to navigate to home or you try to navigate to search page, and we could do the same thing with the details. And we're going to intercept that, and we're going to go and fetch get logged in. Who's currently logged in? So by the time you actually get to those pages, you already know who's logged in, right? So you can write logic that shows certain things depending on who's logged in or not. Make sense? So we're going to intercept the navigation to those pages and have someone logged in or not by the time you get there. So get logged in is implemented down here. It's the same implementation we had earlier for check logged in. Whereas check logged in resolved or rejected whether somebody was logged in or not to protect a page. Here, we're never going to reject. We're never going to reject. we're going to go fetch the current user using the same user service we had earlier. And in our resolve, we're going to update the current user with the current user in the server. This might come back as null or not, right? This might come back as an object or as null. If there's somebody logged in, it comes back as an object. If there's nobody logged in, it'll come back as null, right? And we will appropriately update that in the root scope, right? And notify everybody who wants to know if there's currently somebody logged in on the client, right? But regardless, notice that there's no if statement here whether it was null or not, right? We are always going to resolve. So we're always going to let you pass, right? But by the time you get there, right, you will know whether somebody's logged in or not. Okay? We're going to resolve and let you through to the home view or the search view. Okay, make sense? Yes.
So can we consider this that the only difference between a session and the root scope setting would be that root scope cannot handle a refresh, but
Exactly.
can. Otherwise,
Right.
they are identical.
Well, identical. The thing is that, I mean, we're using the root scope as a temporary solution, right? Or as a convenient solution to notify everybody who cares about this application-wide state, that somebody's logged in or not, right? So that's what we're using the root scope for. And before we looked at session, that was the only mechanism by which we could remember session-wide or application-wide state. Okay, but it fails to survive a refresh, right? Because the browser just throws everything away and you go back to the original state, right? What we're doing here is that what we're saying is that that kind of state information should not be managed by the client, right? It should be managed by the server. The server is going to have access to be able to remember things across many requests. It's going to have access to the server, right? It's going to have access to encrypted data, right? That is just not available in the client, right? So what we're doing here is that anytime you really want to know if anybody is logged in, right? We are going to go back to the server to find out about a login state, right? And we're only going to use the root scope on the client as a convenient way to notify everybody that, hey, I just checked with the server. Yes, this person is logged in. I'm going to notify the entire application that this is the current user. But whenever the question goes to check to see if anybody's logged in, it's always going to go back to the server and find out who it is. And I'm going to conveniently update my root scope. Right? But it always, so if you refresh the home page or the search page, it's always going to be intercepted by get logged in. And it's always going to go back to the server to retrieve who's logged in. See that? Right? And I'm going to notify everybody through the root scope. Right? We could do away with this. We could do this, do away entirely with this, right? And provide the data of this function, this response data. Actually, this response data, part of this deferred, we can pass it in the resolve the current user, right? We can pass the data in the resolve, and it would be available at the control level, right? At the control level. As part of the resolve API, okay, which we could look at a little later, but we can do away entirely with the root scope. Yes.
If you pass it within the resolve, so
yes.
Then we don't need to use.
We could do away completely with the current scope, root scope. Yes.
Why we don't use as a local storage?
You could use local storage. Local storage. It's
so we can have
it's a cookie on steroids, right? It's like a database, a huge database where you can store things.
Have a username and logged in flag.
Yep.
So if that logged in flag is set, then we are all good. But
yes.
if that logged in flag is not set, we can just have the username and we can just provide.
Yeah, you can do that. You can do that. Yeah, you could augment this, right? Because right now we're using a cookie, right? And the only thing we're storing in that cookie is a session ID, right? We're not storing any data in the cookie, right? We're just using it as an underlying framework for the server to identify whether we're logged in or not, right? And the data is always being provided by the server. The problem of storing data on the client is the danger of becoming stale, right? Especially if you have data that is being shared amongst several users, you know that. So, for instance, right? If I navigate to a particular movie and I see data there, is this data that is stale? Am I looking at data that is current or not, right? And there's a whole bunch of caching mechanisms that are supported. And I would prefer that you use Angular's caching mechanism, right, to keep track of cache data, right? It works well with the model, right? It works well with listeners and observers, and and the propagation of data across the entire framework. Whereas as opposed to local storage, which is a low-level API, right? It's a low-level API as opposed to the high-level caching API supported by Angular. All right, we did that. All right, so by the time we get to the home view and the search view, we have the person logged in. Let me turn this off. Let's keep going. So, added search field. Oh, okay. So we're gonna augment the search view so that we can actually search for movies. Okay. So we have here an input field and a button. So this is just this, right? It's this over here, the search field and the button, and we're gonna have a controller for that. We're gonna have a controller for the view, and here's my boilerplate controller for the search view, and here's my event handler for when they click on the search button and they pass me the movie. And any communication, any searches are going to be encapsulated with an OMDB service, right? So anytime we're going to interact with some data source, whether it's our own, right, for the users, right, we're always going to encapsulate that communication with the data source through a service. So here's my service that I'm going to use to interact with OMDB, right? So there's an API that I'm creating that allows me to search a movie by title, which the controller is going to use, right? The controller is going to pass the title that the user typed, right? We're going to pass it to this service. There it is. It's passing it. We're injecting the service, and it's using it to pass the movie title to the service, and now the service actually does the call to the OMDB API, right, using that URL, and it returns a promise. Right, returns a promise to the controller, and the controller uses that promise to register our callback, right, and the response, the data in the response passes it to the client for rendering, right, and on the client side, we use ngIf to render our search results. So this H3 here comes up when we do it with this. It's this search result here, right? That comes back if there is a results, right? Notice that the way we implemented that was this ngIf, right? This data, this model.data was provided by the controller, right? It said vm.data, right? From the response.data. It's made available here in the client on the view, and notice that we use ngIf. If we're saying that if model.data is truthy, meaning it's not null, it's not undefined, it's not empty string, it's not false, and it's something, it's some object, right? We want to render this content. Notice that we use ngIf as opposed to ngShow, right? ngShow, the way ngShow works is that this div is part of the DOM. It's just not shown, right? It uses styling display none to hide the content. That's different than ngIf. ngIf doesn't even add the content to the DOM, unless the expression is truthy. So if this is truthy, then this entire div is added to the DOM. Otherwise, it's not even in the DOM, right? So I don't want to litter. So ngIf is useful if I don't want to add extra content to the DOM if it's not even going to be shown, right? So here's the table. I get a hold of the array of the search. I just iterate. So this we saw this already, right? We're just showing the results from the search. I'm going to add a details view, so I can navigate to the details view if I click on a particular movie, right? And the route, I don't have the route yet. Oh, okay, yeah. So I have details here, and I have in the config. Wait, where's the routing? Oh, okay. Notice the routing, right? The routing is not just /details, but I append. It'll have a parameter, right? The route has a parameter, meaning I will navigate to this view if it's /details / something, right? And that something I'm going to interpret as being the ID of the IMDb ID, okay? And that will be made available in the controller as the route params, right? In the header, I'm going to add a link that will only be visible if the URL contains details. See that? Using index. Look at all the other ones. All the other ones are your model.url is equal to profile. See that? Whereas this says if it contains details. That's because this route is not just /details. It's /details followed by something, right? So that's why it's just a little more involved. I'm just checking to see if details is in the URL. Okay. If it's in the URL, I want to make it active, and it will only appear if I'm navigating to the page. Okay. So you see that. Notice that the details link is not there. See that? It only appears if I click here and I navigate, and it has this pattern, and then I have the details page. See that? So if I go to search, it goes away. Right? Maybe a better implementation would be that it's there if there has been a search, right? If there has been a search, and if you have clicked on the details, right, it'll always be there. If there has been if you've ever navigated to the page, maybe that'd be a better implementation. I'll change it to that. Then the controller. The controller is going to is going to be invoked when I navigate to the details page. So that's a boilerplate controller. What we're going to do is that we're going to extract the IMDb from the parameters, so that controller declares route parameters, and it's going to extract the IMDb from the route parameters. And now that I have the details. Now that I have the IMDb, I'm going to pass that IMDb. Now that I have the IMDb, there it is, right? I'm going to, from the controller, I want to ask the the OMDB service to find me a movie for that IMDb, and I will wait for it. I will wait for that movie registering this function, notify me, calling me this function. So to implement that in the service. We add the API, find movie by IMDb, which goes off to the IMDb URL with the ID that you pass it, and then it just returns a promise, right, that eventually will come back from the server, from the OMDB server. And the controller receives the response, extracts the data, passes it to the view for rendering, right? So the details page will render the title in an H3, the image, the plot, the actors. We saw that already, right? Okay. So now we want to add favorites, right? We have that button that we want to click on and notify the server that says, hey, this particular user favorited this particular movie, right? So we're going to add a button in the details page that is going to notify the controller if they click on this. Right? If they click, and it passes the ID of the movie that they like. Right? In the controller, we're going to have an event handler that's going to receive that event. It's just going to pass, just print out the IMDb to the console. Wait a minute, get logged in. Oh, okay. So the details page not only needs the ID of the movie that they liked, it'll also need the ID of the user that's currently logged in, right? Because it needs to make a relationship between the two, right? It needs to know, it needs to inform the server that so and so likes so and so movie, right? It needs both things. So because it needs the session, right? Because the session maintains who's currently logged in. I added the resolve to the details page as well, right? Any page I want to provide the current user, I can use the resolve. All right. So now by the time we get to the details page, the current user is stored in the root scope. Although it would be better to use the user service instead. Right? Use the user service .get current user, which is the same thing, right? But it would look the code would look better. Anyway, now I have the current user. Now favorite not only has the IMDb, it now also has the user name, right? It has the name of the username. It also has the ID of the user in the current user. I'm just verifying that I can print, right? Also notice that if there is no current user, I'm going to kick you back to the login page, right? That's why I'm injecting the location service in the controller. See that? Let's see. So all right. So I'm going to create a movie service. So it says, wait a minute, don't we already have a movie service? I mean, we're talking to OMDB. I mean, that's a service talking about movies, right? But I need two services. One, to talk to OMDB, right? That's going to encapsulate all my communication to this API, right? I need to do two things. I need to be able to search by title. I'm going to need to search by IMDb, right? But I also need to talk to my own service, right? My database. Like, for instance, if they like some movie, I need to store in my database, right? And create a relationship and say that so-and-so user likes so-and-so movie. I need to see if the movie is even there in my database, right? If nobody has liked anything and they're using they're just browsing from movie to movie, there's no need for me to store anything in my database, right? I'm always using the OMDB service. But if I need to remember anything, I need to talk back to my server. So my movie service client is going to encapsulate all my communication with my server about movies. So I have several services. I have the user service, which is not listed here. So I have the user service client, right, that talks to my server about users, and I have a service about movies that talks to my server about movies. So usually each entity, right, should have its own dedicated service. Okay. So here's my movie service. Here's a boilerplate for the movie service. Up to have an API to be able to set the fact that so-and-so user likes so-and-so movie, right? And it's going to receive as argument the ID of the user and the ID of the movie, and the controller, right, has the ID of the user and has the ID of the movie. It's going to use a movie service. Right, we're going to inject it, right, and we're going to use the set user likes movie, passing the ID of the user and the ID of the movie. We need to notify the server about this, right? That so-and-so likes so-and-so movie. So the service, instead of just echoing the user ID and the movie ID, is going to notify the server and say, hey, this user likes this movie. Notice the API that we're using, we're posting to our project to this user, the user ID. So this is like a one-to-many. Right? So this is a one-to-many from the point of view of the user. And it says, hey, I like this movie. Saying this is the hierarchy, right? This user has a relationship with that movie. Notice that right now we only have one relationship, right, which is that the user likes the movie, right? So this makes sense, right? User, movie. There's that one relationship between users and movies. But when you start thinking about many types of relationships where a user likes it, user comments, those are all three different types of relationships between users and movies. See that? So later on, we're gonna have to come back here and be able to distinguish between these three types of relationships, right? Over here, there's only one, so it's okay to have user and then just movie. But if we want to distinguish between the three types of relationships, what we might want to do instead is say user ID, likes, and then the ID of the movie, right? Instead if it's a review, then it would be user ID, review, right, and the ID of the movie. And then post an object that contains the review, right? See that? So we'll come back to this implementation so we can distinguish between different types of relationships, right? So and it would read much better, right? User likes the ID, user reviews and then the ID of the movie, or user rates that movie. See that? And it would be stored in three separate collections on the server. Make sense? Right? So on the server side, my top level app.js, right, just had one service and one model, right, which was just a user service and the user model, right? But now we're going to have a separate service that is dedicated to the movies, yes? And we're going to have a model also for the movies, right? We need to store movie information, right? We need to store the poster, we need to store the IMDb, we need to store the title of the movie in our database, right? So I'm going to rename my model and service, which had just generic names, model and service. I'm going to rename them to user model and user service, right? Because I need to distinguish it from this new service called movie service. You see that? So everywhere where I had user model or just model and service, I rename it. So where I had model, now it's just going to be user model. And this is brand new movie service. This movie service, here it is, right? It's listening. It's listening for user ID, movie ID, IMDb, right? And it's going to map. It's going to be implemented here. User likes movie, right? Right now it's receiving the user ID and the IMDb, right? And it's just echoing it just to make sure that we are receiving this from the client correctly. Yes. Just like there's a movie service, there's going to be a movie model, right? So we have a user model, user service, and then we're going to have movie model and movie service. Okay, and the model is responsible for manipulating the data, right? So we're going to need what we're going to need is we need to tell the user. Remember, the way we're gonna capture the relationship between the user and the model and the movie is through arrays, right? We need to tell the user, right, what movies they like, and we need to tell the movie what users like it. Yes. So we need to find the movie, right? We need to find the user because we need to manipulate both of them, right? So here's movie. And we need to find that movie by the ID because we have the ID of the movie, we have the ID of the user. We need to find these two, right? So here's the find movie by ID. There it is. And I'm going to store movies right now as a local array of movies. Eventually, this will be a collection, right? It will be a collection in the database, right? But for now, it's just going to be an array that it's a variable in the Node.js memory space, right? And to find a movie, I'm just going to iterate over those arrays. And if I find it that the ID is equal to the IMDb, I'm going to return that movie instance. Very simple, right? In the service, in the movie service, before it used to just take the user ID and IMDb and just echo it. But now that the model has a function, I can actually look for that movie and send it back. Well, I actually don't send it back, but I could send it back, right? So I find the movie. Now that I have the movie, I could start updating the array like that movie, right? And that's exactly what we do here. Right. Now that we have the movie instance, we check to see if the movie, if the model found the movie, if it's not null, and we check to see if it has any previous likes. It might be the very first time that anybody likes this movie, right? If that's the case, we initialize it to an empty array, and then we push the ID of the user into the likes of that movie. So now the movie knows that this user likes it. Yes, right. So it has a reference to the movie, to the user, right? Okay. So that's if the movie exists, I will retrieve that movie and say, hey, this user likes you. What if the movie doesn't exist? Right, because it's not in my database. Right, it's not in my database. I need to create one. So, so I'm going to add to the model. I'm going to add a create movie, right? And the create movie is going to take the IMDb. It's going to copy it locally. It's going to create an object, a movie object, and it's going to that has the IMDb, and then it's going to push it into the current array of movies. Okay. So I've created this. We're going to have to revisit this later, right? When we introduce MongoDB. In MongoDB, we would be doing an insert right into the movie database, into the movie collection, right? It would be an asynchronous call, so we're gonna have to add, all those cool, all those necessary promises. So on the server, now that we can create a movie, we can go back to our service and search for the movie. And if the movie doesn't exist, if the movie doesn't exist, right? This comes back as null, right? That movie doesn't exist in our database. We're going to create the movie with that ID. We have the new object. We check to see if it has likes, and we just push the user into that array. Okay. Oh yeah, I had a bug here, which I was passing the user ID to the find user by IMDb. I just removed that. Okay, so now we've done everything we need to notify the movie of all the users that it likes, that like it. We have to do the same thing for the user. We have to find the user by ID, right? And then notify it that this movie that it likes this movie. So in the model. In the same place where I'm updating the movie, I need to also update the user, right? So I need since the movie service needs to manipulate the users, I pass it the user model. User model, I implement a find user by ID. I didn't have one before. This iterates over the array of users and returns the user when it finds that user ID. And in the user likes movie, we already notified the movie of which users like it. We have to do the same thing for the users, right? We're going to find the user. We check to see if that user likes anything. If it doesn't like anything, we're going to initialize the array to empty. And then we're going to push the ID of the movie for the user. So now both ends know about each other, right? The movie knows about the user, and the user knows about the movies. Okay. All right, let's leave it here. We still have to return them. Notice that we're not returning anything yet, right? We're going to have to return this back to the server, to the client, so the client can render, right? From the movie's point of view, the users that like it. Or from the user's point of view, the movie that the person likes. Okay, and we'll come back. We'll pick up this next time we meet. All right. Thank you.